Hey everybody, it's Mr. Carr again. Today we're going to be looking at 4.1, new unit on similarity, and specifically a lot with triangles as well. So our first part, 4.1, is talking about similar figures. So what does it mean to be similar? Similar polygons are two figures that are the same shape but different sizes. So a quick example of this, if I have a triangle that looks like this, okay, and then I take that triangle and here's a second one. These are congruent right now. Similar means that it's either bigger, but still the same overall shape, or it's smaller. Okay. So that's what we're looking at for these cases. Here's important. In similar polygons, we still have corresponding sides and corresponding angles, but corresponding angles are congruent, whereas corresponding sides are actually proportional. So that means that everything is multiplied by the same number to get to those sizes. So for example, here I've got A and X are going to be congruent, B and Y, and C and Z are congruent to each other. But the sides are not the same, they're proportional. How they're proportional is what's called the linear scale factor. That's the ratio of the lengths of the corresponding sides. So let's explore what that looks like in this first example here. First thing is, here's my similarity statement. I read this as triangle ABC is similar to triangle DEF. Okay. So that's what it means with this symbol here. Looks a little like our congruency symbol, but it's missing that equal sign underneath. This means it's similar to it. So we want to list all pairs of congruent angles. Just like with our congruency statements, we can find congruent angles just from here. So for example, A and D are the first letters. So I know that angle A is congruent to angle D. B and E are in the middle. So angle B has to be congruent to angle E. And then finally, C and F are the last letters, so that angle C is congruent to angle F. I like to mark that in my diagram here just so I can keep everything in order. So we have, it was A to D, B to E, and then C to F. Right there. Okay. So check the ratios of our corresponding side lengths are equal. So what I mean by that is, if we look at ratio 1, I'll do the first two letters. So that was AB, which is 10, and DE, which is 15. I don't have to, it doesn't matter which way I do it. I could do 15 over 10 or 10 over 15. Just be consistent as you go through. So if I'll go left over right. So I'll make that 15 over 10. Dividing that out by 5, I get 3 over 2. So let's do the same thing with BC. BC and EF here. That's 12 and 8. So that's 12 over 8. So if I divide both of those by 4, I get 3 over 2. So last one is going to be AC and DF here. So it's going to be 18 over 12. So if I divide by 6, I get 3 over 2. Since they all are the same ratio in the end, that is my linear scale factor. It's my LSF here. Now, in this case, I did it as the larger on top versus bottom. If it's not being specific, so this is the ratio of, oh, sorry. You know what? I do have to flip these. My bad. I did make a mistake here because it does say linear scale factor from ABC to DEF. So if I'm looking at from ABC to DEF as a ratio, I'm going to do that as ABC over DEF. So honestly, I need to flip all that. So, but it's the same stuff overall. So if I just do this, yeah, let's just erase here. Everything, well, that's fine. Okay. So it's all going to be the same thing, but I'm going to flip them now. So I should have read that a little more closely. So I'm going to put, it was 10 over 15, which is 2/3. And then it was 8 over 12, which is also 2/3. And then it was 12 over 18, which reduces to 2/3. So my linear scale factor in this case is 2 over 3. If I switch that, if I instead I said DEF to ABC, I'll put DEF on top and then that just everything flips. It's the same thing. So the worker we already did on that one, that was the opposite version of that. So let's use our scale factor in this case. In our diagram, we're given that these two figures are similar to each other. We want to find our scale factor from FGHJK to this one. So again, I'm going to put this on top. What I need to do is find a pair of corresponding sides so I can actually establish my scale factor. So for example, that's AB is 10 here. AB is the first two letters, just like FG. So that's going to be 15 here. So I know for a fact those have to be corresponding because of their positions. But now instead of congruent, they're not the same as each other, but they are proportional to each other. So I'm going to put FG over AB, which is 15 over 10. Dividing by 5, I get 3 over 2. So that's my scale factor of FGHJK to ABCDE. Now that I have that scale factor, I can find my missing value of x here. Scale factor here, 3 over 2, is going to be the same ratio as x to 18, because those are in corresponding positions. So I did 3 over 2. I said x over 18. That's going to be 18 over x, because I did 15 over 10. 18 goes over x. You have to be consistent. If I do bigger over smaller, small over bigger, just have to be consistent when you set that up. When two fractions are equal to each other, we can cross multiply them. So we get 3 times x is equal to 2 times 18. That's going to give me 36. Divide by 3, and I get x is equal to 12. Okay. So our last example here, length of the sides of a triangle have a ratio of 2 to 5 to 7. If the perimeter is 84, what is the length of the biggest side? These can be a little bit tricky, but I like to do it as like a bit of a ratio table here. What I mean by that is this: if I have a triangle, so we have a triangle here, and the sides, my ratio sides are 2, 5, 7. Then I'm going to put perimeter at the bottom. So what I mean by that is I'm going to have 2, 5, and 7. Adding those up, I get 14. That's the perimeter of this basic triangle. That's the sides of 2, 5, and 7. The perimeter of the real triangle is 84. So what is the length of the biggest side? That's going to be this length right here because it's lined up with the 7. Using this table of doing my ratios compared to the real triangle like this, I can now just do my cross multiplication with this. 7 over 14 is equal to x over 84. So now I will take this, I'm going to just divide by 7, make it a 1, and divide by 7, make it a 2. A little bit easier if I make it smaller numbers, in my opinion. Now I can cross multiply with 2 times x, so 2x. 1 times 84 is 84. Divide both sides by 2, and I get x is equal to 41. So that's going to be my length of the biggest side, which doesn't have any units here. Okay, so we're talking about similarity. So again, the idea is that angles are congruent, but sides are proportional. So we're finding that proportion using what's called the linear scale factor, and we can use that to find missing side lengths then. So that's our setup for today. That's all for our similar polygons. Okay, that's it for that. Take care, everyone.